Hi, good morning, everyone. My name is Anna Ro. I'm a applied scientist from AWS SageMaker Reinforcement Learning team. It's my great pleasure to do this presentation today. My topic is build, train, and deploy RL-lib models on Amazon SageMaker. So what is Amazon SageMaker? It is a fully managed service that provides every developer and scientist with the ability to build, train, and deploy machine learning models quickly. It provides an integrated Jupyter Notebook interface for easy access to your data, and you don't need to manage servers. It also provides common machine learning algorithms as well as the RL-lib algorithms for reinforcement learning. You can deploy a reinforcement model into a secure and scalable environment by launching it with a few clicks. So in a nutshell, SageMaker makes it easy for you to build, scale, and apply your RL models in practice. Before we dive into the service itself, let's just take a look at what it means to build a typical machine learning / reinforcement learning workflow in practice. Unfortunately, it's a pretty difficult task, and you have to go through a number of different steps. There are so many tools you can use for each of them, and everything needs to line up perfectly if you want to build a successful model and deploy it. So of course, first you need to prepare a data set, either annotate it or clean it. For reinforcement learning, this usually corresponds to the process of developing a simulated environment. Once you have that, you can start experimentation. You can start with trying out different algorithms supported in RL-lib. And once you start to figure out which algorithm is going to work, you need to try different parameters, combinations, neural network architectures, and so on and so forth. That requires a bunch of infrastructure. No one actually wants to manage that, but you have to do it to power those training jobs. Then you need to tune them. You need to extract every bit of accuracy from those training jobs in order to get the best possible model and the best business outcome. Over the time of the project, you're going to end up training hundreds or even thousands of jobs, and it's not easy to recall what you have done last week. Once you have a model with satisfying performance, it comes the hardest part, which is deploying that model in production, where it can start making decisions from requests that your business application sends out. As your RL application becomes successful, you need to scale your hosting infrastructure, and you need to manage everything from high availability to security. You also need to perform health checks, handle node failures under the covers, and perform other routine maintenance. So as you can see, although people tend to focus a lot on RL algorithms, there's quite a lot of stuff that needs to be done if you want your RL project to be successful in practice. This stands in the way of achieving your expected outcome, which is the purpose of Amazon SageMaker. In last reInvent, we expanded on SageMaker and added a bunch of capabilities. We'll look at 2 of them, which will be included in the demo in just one moment. As a reinforcement learning practitioner, you may wonder why Amazon SageMaker can be a good place for me to hold the RL workflow compared to other services such as self-managed Amazon EC2 and AWS-managed Amazon EKS. You must consider the infrastructure, operational, and security costs for each step of your RL workflow, as well as the size and expertise of your RL science team. So typically, people would use total cost of ownership as the financial metric to estimate and compare machine learning cost. And a detailed total cost of ownership analysis conducted earlier this year has shown that Amazon SageMaker provides a better total cost of ownership across teams of all sizes. Specifically, that's over 54% lower compared to EC2 and EKS over a 3-year period. With self-managed machine learning with EC2, you take on the responsibility of provisioning and managing EC2 instances, including instance failure recovery, automatic scaling, and maintaining required security and compliance. You can use the AWS Deep Learning armies with your favorite framework and libraries, and this is also provided in RL-lib. But still, you need to optimize the data access to get high throughput and also optimize your setup for scalable hosting. In contrast, Amazon SageMaker is fully managed. You don't need to build, manage, or maintain any infrastructure or tooling to support RL. Amazon SageMaker also runs your model on auto-scaling clusters that are spread across multiple availability zones. SageMaker has built-in security and compliance for machine learning workloads, so you don't need to invest in additional security. Besides, you pay for storage and network based on your RL usage. Therefore, costs are controlled. Training and hosting are billed by minutes of usage, with no minimum fees and no upfront commitments. You can also use spot instances to take advantage of the unused compute capacity, just like what you normally do with native EC2. Now let's quickly take a look at two of the new released Amazon SageMaker features, which we will include in the demo: SageMaker Studio and SageMaker Experiments. Both of them serve for general purpose machine learning applications, and you can of course leverage them for your reinforcement model training and deployment. SageMaker Studio provides a single web-based visual interface where you can perform all machine learning development steps. It gives you complete access, control, and visibility into each step required. You can quickly create new training jobs, move back and forward between steps to adjust experiments, compare results, and deploy the models to production, all in one place. This gives you the ability to make changes quickly, observe outcomes, and iterate faster. And as what we have mentioned earlier, training jobs can lead to hundreds and thousands of experiments that are difficult to track, organize, and manage. This is true for reinforcement learning as well. In this demo, we use SageMaker experiments that help you with that in a seamless and scalable manner. All reinforcement learning artifacts, including algorithms, parameters, and model metrics, are automatically tracked and recorded. In addition, the system automatically organizes, ranks, and sorts experiments based on the chosen metric. For RL, that's normally the episode reward mean. And then produce data visualizations to quickly compare and identify the best performing goals. With that, let's move to the demo. So this is a demonstration of how to run 3D robot environment with Amazon SageMaker and Ray. On the high level, the workflow consists of 5 different steps. First, you choose the simulated environments of interest. And once you have that, you can choose to either use pre-built Amazon SageMaker reinforcement container or build your customized Docker. Once you have the Docker ready, you can kickstart the SageMaker jobs with the RL algorithms provided in RLlib. While the training job goes on, you can do experiment visualization and evaluation. And last but not least, you can deploy the best performing job in production. We also include homogeneous and heterogeneous clustering with Ray as an appendix. So let me walk you through all the 5 different steps. As for the simulated environment, we choose the classical Richard problem as the environment. And for the sake of time, we skip the permission and configuration setup, but you can find the complete steps in the public GitHub repo. Then you can move on to the second stage, which in this case, you can build a customized Docker. It fetches the pre-built RL-based Docker image out of the box, install the required dependencies, and then later upload this new container image to Amazon ECR, which Amazon SageMaker will use to perform training jobs. Once the Docker is in place, we can start looking at the actual training job. Here is the snapshot of the launcher code. You may find this specific components quite familiar, and indeed, that's the same configuration that you would use with RLlib out of the box. So when using SageMaker, all you need to do is to pass in those same experiment configurations, and Amazon SageMaker will spin up the corresponding training job for you. You can define a SageMaker experiment, and in this case, I call it an Anna Richer experiment. And you can create the first trial with all the default hyperparameter settings and add that trial into the experiment. With the trial and experiment being defined, all you need to do is to make this API call estimator and .fit and attach that training job to the corresponding trial. Then, as you can see from the output, Amazon SageMaker automatically kickstart a training job with this specific job name for you. And you can do exactly the same thing for the other trial, where you can see by the name, for example, you want to experiment with mean and standard filter. Therefore, all you need to change is to have the second trial name and then specify this observation filter in the hyperparameters. As a result, you can see the second job being kick-started. As the job goes on, you can check trials by different ways. For example, with Amazon SageMaker, you can sort the performance of the trials by the specific metric. And in this case, it's the episode reward mean. SageMaker experiment will automatically check out which trial has the best metric. In this case, we only have 2 trials, but it can scale up to hundreds and thousands of trials. You can also trace back the lineage of a given model version by specifying the value of the trial name. And as you can see, the table will give you every information about that trial. For example, the instance type, and all the hyperparameters, and all the metrics. You can do visualization from different methods as well. The first method, as an illustration, is by looking at the MP4 rendered by the job. For example, here, as we can see, this robot indeed has learned a methodology to reach to the target position, which in this case is the red ball. And the training job in Amazon SageMaker. For instance, you can check out the charts, the metrics of the job. As you can see here, this is the trial with the mean and standard filter. You can check out the reward mean on the fly and add charts to include all other metrics of interest. You can also switch between tabs to look at the artifacts and AWS settings of the trial. All those artifacts helps you to reproduce the experiment in an efficient manner. Once you have chosen the best performing model, now is the time for deployment. With Amazon SageMaker, you can deploy it with a single call of model.deploy. It takes a couple of minutes for SageMaker to prepare the endpoint. And after the endpoint is up, you can prepare the input as an HTTP request, and the endpoint will give you the corresponding result. In this case, it's a 2-dimensional action space. With that, we finish an end-to-end RL workflow. Appendix here includes the multiple instance training, where you can do both homogeneous scaling and heterogeneous scaling. For the interest of the time, I will skip this part, but as I mentioned before, those examples are public on our GitHub repo. And let's move back to the presentation right now. So if you're interested in looking at more details, especially for how to perform distributed training on Amazon SageMaker, how to use spot training, and how to do Amazon SageMaker HPO, feel free to check out the GitHub repo. That's Amazon SageMaker examples/reinforcement learning. And that is the end of my presentation today. Thank you, everyone. Feel free to reach out, and I'm happy to take any questions in the Q&A session later on.